Hello everyone. Today let us discuss about AC circuits. It is the most important chapter, and this chapter is so important that all competitive exams, all board exams definitely include one question from this chapter. So from the beginning, if you understand this chapter carefully, it is very easy. But if you don't concentrate on the topics, it is very difficult for you to attempt the questions related to this topic. So, without wasting much time, let us start our AC circuit. In this chapter, we have mainly the important topics are AC through resistance, AC through inductance, AC through capacitance, and LR, CR and LCR circuits, and also transformer is there. Earlier we have LC oscillations also, but recent days it is under the deleted portion. Therefore, mainly under AC circuits we have these topics, that is AC through resistor, AC through inductor, AC through capacitor, AC through LCR circuit, AC through LR circuit, AC through CR circuit. And now what we have to learn for each and every topic. All topics are common for every circuit. Listen carefully. These 5 points are common for each and every circuit. That is, number 1, voltage equation. You can see what I have prepared here. Number 1, it is voltage equation. Number 2, current equation. Number 3, resistance. Number 4, phase difference. Number 5, power. So these are common for all circuits. So we should go in sequence, then it will be very easy for us. Then after that, the next thing is, for every topic, what are the figures required? For every topic, these are the figures which are required. Number 1, circuit diagram. Number 2, wave diagram. Number 3, phasor diagram. These diagrams are common for every circuit. So we have to go in sequence, and the next thing is, you have to prepare a table like this. Once we complete one circuit, you have to fill this table. I just wrote for pure resistance. You make a table. I make my offline students also to write like this, and they will write immediately after completing one topic. So this table contains rows and columns like this. You can see here, we have here the columns with the names, serial number, next circuit, that means type of the circuit, pure resistance, then pure capacitance, pure inductance, and so on. You have to write like that. Next, what is the voltage equation for each and every circuit? What is the current equation for each and every circuit? Resistance, phase difference, power. So make a table like this. Then it is very easy for you to study for the exams. Okay? It's very easy for you. Then when you are going for the competitive exams, instead of studying the full chapter again, just if you see this table, it is easy for you. And you have to write like here, pure resistance, pure capacitance, pure inductance, LCR, number 5, LR circuit, number 6, CR circuit, and so on. So like that you have to prepare. Okay. And finally, after completing the table, you by heart them, learn them, and it will be very easy for you to go for the competitive exams once you learn them by heart. Okay. Now what we will do today, we will discuss first AC through the resistor. Shall we start? Hello children. Now first let us start with AC through resistor. So the symbol of AC is this, the symbol of DC is this. So all these chapters up to third chapter, when we were studying, we used to have a DC battery, we used to use this symbol. Let us apply this AC circuit to a pure resistor. So the circuit diagram first you have to draw with the AC source, and it has a resistance like this. That's all, a simple circuit. This is E and this is R. Now, as we know Kirchhoff's loop rule, the algebraic sum of the EMFs and voltages around a closed loop is equal to 0. So in mathematical form we write it as sigma E of t is equal to 0. That means sum of the EMFs and potential differences around the closed loop is equal to 0. Now whatever the voltage we apply here, that is completely appearing across this resistance, because there is no other device as per the Kirchhoff's loop rule. Now if you see this, just like an example I am giving, suppose if you have a overhead tank like this, and in that tank you have completely water, and the water is coming out, and you have filled another tank, and then after some time the complete water here is over, but the tank in the bottom is completely filled. What does it mean? The water which was there in the upper one, that is the first tank, is equal to the water in the lower tank. Why I am giving this example is, it is the same thing what we are talking now. Applied EMF is like the overhead tank, then that is completely appearing across the resistor as the PD across the resistor. This example I just gave you to understand the concept of Kirchhoff's rule. Already I have explained Kirchhoff's rules in my another video. You can go through that and you can see that. Now coming to here, now this is the Kirchhoff's rule which we have applied here. Then what is the applied voltage? Vm sin omega t. V is equal to Vm sin omega t. That is the applied voltage. Let it be equation number 1. Now completely applied EMF appears across the resistance. Therefore voltage across the resistance is equal to, that is according to Ohm's law, V is equal to IR. You all know that. Therefore let us equate it. V is equal to IR. Therefore Vm sin omega t is equal to I into R. So let it be equation number 2. You can say now I is equal to Vm sin omega t divided by R, and you can also write it as Vm by R into sin omega t. This is the equation for the current. Now where you can see Vm is the peak voltage, therefore you can write Im, that is the maximum value of current or peak value of current, is equal to Vm by R. Substituting this value here in this equation, we get I is equal to Im sin omega t. That is equation number 3. Now we got voltage equation, we got current equation. Previously I have already told you, for each and every circuit the first one is voltage equation, and the second one is current equation, and the third thing is resistance. If you see here, Im is equal to Vm by R. So you can see from here, resistance of the circuit is R only. So let it be equation number 4. So we got 3 points now, and what else is there now? We have to know now the remaining things, that is the phase difference as well as the power. Now let us see the phase difference. If you see the equations, that is V is equal to Vm sin omega t, that is voltage equation. I is equal to Im sin omega t, that is the current equation. After sin, you can clearly see both of them have omega t and omega t. That means there is no phase difference between voltage and current, because after sin both of them have omega t and omega t. When you go to inductance circuit, in the inductance circuit you will get I is equal to Im sine omega t minus pi by 2 you will get. So that means here there is a phase difference of 90 degrees between voltage and current. Similarly, when you go for capacitor circuit, there you will get I is equal to Im sine omega t plus pi by 2 you will get. There also phase difference is pi by 2, that is 90 degrees. But in the case of inductance, voltage leads, which is omega t. In the case of capacitor circuit, current leads, that is plus pi by 2. Now you can clearly see here it is minus pi by 2, here it is plus pi by 2. All those things I will explain later again. I am just showing you the phase difference will not be the same all the time like the resistance circuit, because here there is no phase difference. Therefore we can write that phase difference between voltage and current is 0, because there is no phase difference between voltage and current. So another point is over for now, and what remains is the last point, that is power. So we have to see now power equation. Now let's go for our power equation. We all know power P is equal to V into I. V into I. So here that is also equal to I square R. You know that formula. So you can write P is equal to Im square or sine square omega t. How? Because I is equal to Im sine omega t. Therefore, in place of I, if you substitute this, you will get Im square sine square omega t, and it is multiplied with R. So now you can write it as the average power For average, we put a small bar on the top, that is P bar. When you put P like this on that, this is a vector. When you put just one bar without arrow, that is average value. So we put average, that is like this, is equal to average value of I square R, that is equal to average. If you keep in triangular brackets like this, it is the meaning of average power. So that is equal to Im square or sine square omega t. This is the average value. So when you keep the triangular brackets, that it tells us the average value of the quantity which is there inside the bracket. Now in this case, if you see here, this Im square and R, they are constants. So you can't take average value for that. So therefore take them out. Therefore you will get P bar is equal to Im square R. Within the triangular brackets you will get sine square omega t. Sine square omega t. Now after that, if you see in trigonometry, sine square omega t you can write as 1 by 2 1 minus cos 2 omega t. Like this you can write. Okay. Now you have to take the average value for this, taking the triangular brackets here. Now what will happen here? 1 by 2 is a constant, you can take it out. 1 by 2, and then it will become 1 minus triangular bracket cos 2 omega t, because that is the only thing which is changing with time. How can we say? Because there is omega t here. That means it is a time dependent quantity. When it is a time dependent quantity, it is changing with time, especially when we come to sine functions and cos functions. They change with the time. When they change with time, the wave form of the sine wave and the cos wave, you know earlier, the waveforms are like this. Here half positive cycle, half negative cycle. Then if you take on an average for a full cycle means from here to here. So this is the full cycle, average value becomes 0. This is a sine wave which starts at the origin. And suppose if you want to take the cos wave, it starts like this because cos 0 is 1, the wave comes like this. Even then, half cycle positive, half cycle negative, on an average, this will also become 0. So, you should know the average value of sine and cos over a full cycle, it becomes 0. That means this second part will become 0. But the first part you have this one half. So therefore average of sine square omega t, it is 1 by 2. So you can write sine square omega t between the triangular brackets, it is equal to 1 by 2. Therefore when you go back to this equation, p bar is equal to im square r sine square omega t average is 1 by 2. Therefore it will become half im square r. Okay. So now you can write the power equation. You can write like this. P average power over a full cycle in a pure resistor circuit im square r. So this is the power equation. So here we wrote the equation numbers. The last one which wrote is 5. So now you can write it as equation number 6. Equation number 6. Now if you go up and check once again, let us check again all the things. We need to know totally 5 equations as I told you in the introduction. Here we got all the 5 now. V is equal to Vm sin omega t, that is the voltage equation, and the next one is I is equal to Im sin omega t, that is the current equation, and then we need to know the resistance of the circuit, that is resistance is equal to R, that also we got, and then we need to know then phase difference, that also we got here. The phase difference is 0, that is also over, and the last one is power. We got the power equation here, that is half Im square r. This is all about the power. Now let us take power in RMS values. You know RMS values, no? IRMS is equal to I peak divided by root 2. Similarly, VRMS is equal to V peak divided by root 2. So these values are called as RMS values. I hope you know them. Therefore, we can take them, that is power equation. Once again I am taking and continuing because I want to express it as the AC power. Then it will become P, capital letter I am using. Earlier I used small letters, that is average of power half Im square r, that is equal to, you can write it as Im by root 2 into r. So Im by root 2 is, that is IRMS, which we can take as capital I r, which is equal to I square r. So in this way, once again you got the power equation, which is equal to I square r, just like our third chapter DC power, I square r, V square by r, V into I. Like that we got this equation for the power. Now 5 equations are over, and already I told you in my introduction, every circuit should have these 5 equations, that is voltage equation, current equation, resistance of the circuit, phase difference of the circuit, and the power of the circuit. All 5 points are over. Now I told you for every circuit we need to know 3 figures. Those figures are circuit diagram already, which we have drawn in the beginning, And the next thing is we need to draw the wave diagram. So to draw the wave diagram, always voltage position is same. There is no change in the voltage position. This is the voltage 1, which you can say as V, and this is the peak value of voltage Vm. And as you know, V is equal to Vm sin omega t, whereas I is equal to Im sin omega t, whereas Im is equal to Vm by R. That means peak value of current Im is less than Vm because it is divided by R, Vm by R. Therefore, current you can draw like this because they are in the same phase. Both will reach maximum value at the same time. Both will reach minimum value at the same time. Clearly, very clearly you can see here. Both of them reach the maximum value here at the same time. Both of them become 0 at the same time. Both of them reach maximum negative value at the same time. And again both of them will become 0 at the same time. So it goes on like that, 0, pi, 2 pi and so on. So here we have taken omega t on x-axis, and on y-axis we are taking Im and Vm. So this is Im, whereas Im is less than Vm. So like that you can take, this is the wave diagram. Okay, so on x-axis we take omega t, and on y-axis we take the values of voltage and current. So wave diagram is also over, and what is remaining now? The last point. The last point is nothing but we have to take the phasor diagram. So phasor diagram, what are the phasors? Phasors are nothing but rotating vectors. So phasors are nothing but rotating vectors. What are these rotating vectors? They are nothing but vectors, but they are rotating anti-clockwise direction. Let us take the phasor diagram in extension of this towards this left side. You can draw like this. At any instant of time t1, at any instant of time t1, let this is omega t1 is the value, and take some straight lines like this onto the top. And now you can take here onto the top, and when you are drawing in the beginning you can make it as a practice. Draw straight lines like this so that you will not get problem like this. Then how to draw these phasors? So you can draw for voltage which is making an angle omega t with x-axis, and which has more magnitude like this, which makes an angle omega t1 at the instant of t1. And the next one is current is same angle. So you can write on the top of that, this is current. So this is voltage and this is current. Both of them are like this, and they make same angle with x-axis because both are in the same phase, and they rotate like this, anti-clockwise direction. So this is the phasor diagram, and this is the wave diagram. So with this we have completed all the figures and all the 5 points. Shall we revise? What are the equations we have done? Voltage equation, current equation, resistance, phase difference and power of the circuit. And figures what we have taken: first circuit diagram, next wave diagram, next we have taken phasor diagram. So at any instant of time the equations of these will become, that is V, here you can see V is equal to Vm sin omega t1 at the instant of t1. Similarly, I is equal to Im sin omega t1. So with this I have completed complete details about the first circuit, that is the circuit of pure resistor when applied with AC circuit. The first topic is AC applied to a pure resistor is completely done. Here you can see the wave diagram of AC circuit applied for a pure resistor. And you can clearly see here current and voltage, they reach maximum and minimum values at the same time. The minima 0 and maxima occur at the same time for both of them. Okay, this is the wave diagram which I have shown here in the last slide. Thank you for watching. Let us meet in the next video with the next topic, that is AC applied across the inductor.